Hi, my name is Avi Nabel, and welcome to my Physics Lab 1, Constant Velocity. Here's a table of contents of the topics I'm going to cover in this video. Getting started with my introduction. The purpose of this lab was to compare an object's position recorded in a video versus its predicted position. We had to record a video of an object rolling with a constant velocity, meaning one direction, no acceleration. I chose a guitar slide and rolled it across my floor. Then, I put the video into the software tracker, and from there I observed its position. I also used glow script code in order to see the predicted position. The fundamental physics principle used in this lab was Newton's second law, also known as the momentum principle. It states that F equals P over T, or force is equal to momentum divided by time. We can derive this equation to get the velocity update formula, or final velocity equals initial velocity plus net force divided by mass times time. And because if F net is 0, then acceleration is 0 and velocity will be constant. Now getting into my procedures. First, I recorded the motion of my guitar slide with my iPhone camera using my ruler as a size reference. Then, I uploaded that video to Tracker and marked the position of it frame by frame, resulting in a graph of the time versus position. Then, I created a computational model in GlowScript using the provided starter code and inputting my found data, such as initial position and velocity. After that, I compared my findings between the computational model and recording using an Excel graph with both. Here's a short video demonstration of my tracker. We can see the little red dots are each of the positions that I marked frame by frame. And here on the right side is the graph of the position versus the time. And then here's my analysis of the tracker. So we know that the total time it took for the slide to roll from side to side is 2.4 seconds. And then I can also find the initial position and the initial velocity. Initial velocity is equal to delta x over delta t. And doing this math gets you 0.06963 meters per second. Then I also used GlowScript to create my computational model, and we were provided starter code, so I only had to modify a few lines. Here I modified the initial starting position and velocity vectors. Here I set delta t equal to 1 over 30 because my phone recorded at 30 FPS. Here I set the total time to 2.4, which was based on my tracker findings. I set the net force to 0 because we want a constant velocity, and then I updated the equations using the kinematics equations. Here's my comparison between my predicted position in blue versus my actual position in orange, and we can see that there is somewhat of a disparity here. Possible errors. There is a possible human errors. It is possible that I messed up when placing the marks in the tracker. It is also possible that I messed up when rolling the slide across my floor. Outside forces. In the predicted model, I did not account for friction or air resistance, which could cause some disparity. It is also possible my ground was slightly sloped, giving the slide a non-zero acceleration. What if I switched the axes? If I put time on the y-axis and position on the x-axis, the slope would simply be the negative of what it is now, but the physics would remain the same. Is there a net force of 0? No. The computational model did not account for forces like friction or air resistance. It simply ignored these forces. However, these forces were present in the actual model. Thank you.